Yes. So a farmer needs to fence a rectangular pasture adjacent to a river. He needs 180,000 square meters in order to have enough grass for his herd. What dimensions should be used that would require the least amount of fencing if no fence is needed along the river? Okay, well, let's go step by step. So, a farmer needs to fence a rectangular pasture adjacent to a river. Are we fencing along the river or are we not fencing along the river? So, let's get our diagram going. Here is our river. Thank you, I like it. So, then we are fencing the other three sides. 1, 2, 3. 3 sides of fencing. Okay, so now let's go back. He needs 180,000 square meters in order to have enough grass for his herd. What does that 180,000 represent? Who said it? The area, right? The area inside the fence. So they're saying in order for his animals to be happy, he needs this area inside to be 180,000. Yes, Nico.
Your cable's like unplugging yourself, Laura.
I know. It's just because it trips me. Okay. So now we want to, what dimension should be used that would require the least amount of fencing if no fence is needed along the river? So do we agree the left, since this is a rectangle, the left and right side have the same length? But this one has a different length. I don't care because I'm not closing off the river, so I don't have to put a Y over here. So now we're talking about basically two different equations. We're talking about the area because he says he needs 180,000 square meters for his animals to be happy. So we know the area is equal to length times width. So that means x times y will equal 180,000. But what else are we talking about? What dimension should be used that would require the least amount of fencing? Right? Perimeter, right? So if we're talking about the fencing, aren't we just talking about the outside? We don't really care about the inside. They're saying the least amount of fencing, we need the outside, the perimeter of this. So what do we know for the perimeter? The perimeter is going to equal x plus y. So the perimeter will equal 2x plus y. So now we have our two different equations. We have one with a constraint and one without the constraint. Who remembers what we do now? Nico.
Yeah, isolate the y.
Say it one more time.
Isolate the y.
Good. We want to solve for y. We're going to isolate the y. In which equation? The area or the perimeter? In the area one. So we're going to take the equation that has the constraint, the one that has it set equal to something. This is set equal to 180,000. And we're going to solve for y. When we solve for y, we're going to divide by x on both sides. So now y is equal to 180,000 divided by x. Somebody who's not Nico, tell me, what do I do with that 180,000 over x? Erin. In which equation? Perimeter. So now what we're going to do is we're going to talk about the perimeter in terms of x. So instead of p, I'm now going to call this p of x. Perimeter in terms of x. Our 2x stays the same, but now where I see y, what am I going to plug in instead? 180,000 over x. Which equation do I put into my calculator? Sure. P of x goes into my calculators. I guess you guys need Windows, don't you?
Yeah.
Okay, so let's do our window. I don't even have it written down. Let's do our X window is going to be just do 0 to 500. And our Y window, we will have do 0 to 1,000. Can I go to my calculator? Is everybody done copying this? Okay, let's go to our calculator.
I don't know if it's like frozen, but I think popped up when I did that.
Maybe my window's bad.
Yeah, the window doesn't work.
The window doesn't work?
No, I can't see it at all.
Okay, hold on. I'm going to just try. X min is 0. X max.
30.
30 works?
I don't know.
I'm just going to do mine. You guys might have typed it in wrong. Y min is, I think we need to go higher than 1,000 probably. Y min is, what did I say Y min was? 0?
Yeah.
And Y max, I said 1,000.
3,000.
I said 3,000?
I don't know. No, I'm just thinking about it.
Okay. So when you guys come to type this into your calculator, what you want to do is you're going to do 2x plus, but then you need parentheses. Did you all use parentheses?
Yeah.
You did? Okay.
I did. Nothing's popping up for me still.
Still?
Wait, I write like that. I
Mm-hmm.
wrote my divided by x in the parentheses.
That's fine too. Oh.
Gianna found windows.
Ooh, what are the windows, Gianna?
I found for X 1,500 and for Y 2,500.
Okay, so we have to go bigger. Okay, so we're going to say, what is x?
1,500.
1,500. 2,500? Okay. Okay, guys, we're changing our X max to 1,500, our Y max to 2,500.
You put it in the wrong one.
Oh. There we go. Thank you. Okay, so it says we would want, what dimension should be used to require the least amount of fencing? So do we want a minimum or a maximum? If it's the least amount of fencing, we need a minimum. So we're gonna go, and who remembers how to find the minimum? Second trace, you got it. And we go down to minimum. All right, did you guys get 300? So 300 is our minimum length, right? What does this 1,200 represent?
Max.
Max what?
Max. Okay.
Not max. Minimum perimeter, right? So this 300 represents in our diagram the length of the fence. The 1,200 is not the width of the fence. This 1,200 is what we're finding, which is the minimum perimeter. Nico?
Wait, so we need the y?
No, we need to find the other
Can
y.
you ask for that on the test?
I can.
You should-
So We know, so for the dimensions, x is equal to 300 meters. But now for the y, how are we going to find the y? Look here in your equations. Isn't y equal to 180,000 divided by x? So our y is going to be 180,000 divided by 300. So what is our y? 600 meters. So these are our dimensions. Now let's just say I didn't ask for this, but let's say I asked what is the minimum perimeter? What's the minimum perimeter? What did we say that was? 1200. That's the corresponding y value in your graph. Yes.
How many problems is the thing going to be? The test for this thing?
The quiz?
Yeah.
I think 4. I'm not sure, to be honest with you. No, I don't think there'll be a bonus. All right, let's keep going. So we want to find the coordinates of the point on the curve y equals the root of x that is closest to the point 40. So the first one was similar to what we had done last class, right? This is something completely different. So they're saying find the point on this curve. I don't know if you remember this, but this is like a shooting star. Do you guys remember the shooting star from the beginning of the year? So this is the shooting star. And we want to find a point on the shooting star that's closest to 40. Whenever we're talking about the distance between points, there was a special formula that we used to use. Does anybody remember this? It's like back to geometry.
Don't ask me about it.
All right, so it is the distance formula. The distance formula is, so the distance between points will be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared.
Oh, I remember this actually.
I don't remember this.
I see this like so many times. I was also okay. Me too. That's the reason I moved.
Read this in your class.
Did we do this in the
I
class?
don't remember it.
We did it. But it's at the end of the year. Okay, so don't write this down. I'm just going to show you, since a lot of you don't really remember this distance formula, how it works. So let's say I told you the coordinates for point A are 5, 3. And the coordinates for point B are -1, 7. So what we're going to do is we're going to call A x1, y1. We're going to call B x2, y2. I'm just teaching you how to use this formula. So the distance between A and B is going to be the root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So now you just plug it into the formula. So we're going to say 7 minus, oops, not 7, sorry, -1 minus 5, and then we square it, plus 7 minus 3, and then we square that. -1 minus 5, isn't that a -6? And then 7 minus 3 is 4. Square that. Now you square what's underneath this radical. So you're going to get 36 plus 16. 36 plus 16 is going to be 52. Any pairs in 52? Yes, no, maybe so. Can't you do 5, 2, and 26? And then 2. 26 is 2 and 13. So the distance will be 2 root 13. So the distance between point A and point B is 2 root 13 units long. So this is how you use the formula. All right, now for this formula, we're actually not going to be simplifying much for this word problem, but I just wanted to show you how the formula is used in, I guess, the geometry world. All right, so we're going to use the distance formula. How do I know we're using the distance formula? Because they say find the coordinates of the point on the curve that is closest to the point 40. So they're saying find the distance, the smallest distance. So are we going to be looking for a maximum or are we going to be looking for a minimum? Closest point. Minimum, because it's the closest point we're looking for a minimum. So our first equation we're using is y equals the root of x. The second one we're using is the distance is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay. But this one already tells us that y is equal to root x. So I'm going to now go to the distance formula, and anytime I see a y, I'm going to put a root x. But notice how there's two y's and two x's. So what I'm going to do is I'm going to change it and say this is going to be x2 minus x quantity squared plus y2 minus y quantity squared. The point we're trying to be closest to is 40. Point we're trying to be closest to is 40. So I'm going to call this x2 and y2. So D will equal 4 minus x quantity squared plus 0 minus y quantity squared. So we're getting better, right? The problem is this distance is still in terms of x and y. This distance formula is still in terms of x and y. I only want it in terms of x. So anytime I see a y, what can I put instead? The root of x. So now this is going to be the distance in terms of x. So d of x is going to be the root of 4 minus x quantity squared plus 0 minus the root of x quantity squared. Guys, we're going to be able to plug it just like this into our calculator. Are you ready? Maybe? Okay. Let's go to our calculator. Our window, let's just do 0 to 10. Window min is 0, window max is 0, and y min will also say is 0, y max will be 10. Okay, so now let's enter this in. So it's going to be a little fun entering this in. Do second radical, so second x squared, that gives us the initial radical. So second x squared gives you the initial radical. Now we need parentheses. So in our parentheses, I'm going to have 4 minus x, close those parentheses, and what do I have to do to it? Square it. Now we type plus. Do you really think I need the 0 minus? How many people want to put it? Okay, if you want to put it, we could still put it. So open your parentheses, 0 minus, what was it, root x? So you're going to do second x squared again. That gives you another radical. x come out of that radical. Ooh, no. What happened? I don't know how to get, I'm going to have to erase this whole thing. It's not good. Guys.
Oh, you put the parentheses inside of the x.
I know.
Just delete.
You have to move like out of it.
No, click on delete.
There is no delete.
I don't have delete.
Oh, right here. Oh, there we go. Good. Okay, good. So now we could close the. Oh, I feel so sad for you. Okay. Did we all get this?
No.
I mean, because you had to delete. We can't.
Wait, I messed up again.
Did your graph look like my graph?
No.
Why? What happened? 0 to 10 on both x and y. 0 to 10, both x and y. You want me to go back to my equation to make sure yours looks like mine? Just delete it and enter it again.
Are decimals allowed?
Yeah, of course. There's going to be decimals in this problem. Yay. Daniela, did you get it? Luke? You can't get yours to look like mine? But why? Were you pressing the same button as me?
Well, I mean, like, you can, I feel like 3.5 and 2.
Oh, this is just saying, it just looks a little bit different because you have,
There's
it's
something
still
wrong.
saying this whole thing's going to
Move
be a
out. You have to stay inside the radical.
It did a radical
This
and then
is
parentheses.
square.
It was? What was mine?
Look at mine though. It's like stretching all over.
Yeah, mine doesn't do that.
Oh, you need to do another parenthesis.
Because I tried. Like,
This
I tried
initial
to mine
parenthesis
puts
is
the
the same as
radical and then
everything
puts
that's
the
going on
radical.
the right. So now you need to do
And then when I
another
tried to back
parenthesis.
here with the
Trying to see
parentheses,
it.
4
yeah.
minus x
It's something that you could be.
squared
So I have no idea where you're going.
close that parenthesis plus
You can't like,
open another
you
parenthesis
can't like go
plus
over
0
here and
minus
go.
y.
No, this is right here.
That's you stop there.
No.
That's what I'm saying. I can't.
Parentheses for the x.
Yeah, it goes
Another
down.
parenthesis for the 0 minus. So it's actually refunding the radical, then you can put it in
Where do you
parentheses.
think it's lost?
You put a random parentheses there.
There's 2 second trees. No, every time I put the radical, when I put a radical in my calculator, it just puts a parentheses after I do it.
I'm gonna have to delete that then.
It won't let me. Like, I'll show you. Like, I'll
It's gonna,
I'll do
it's
it
gonna
again.
screw this. Shows out of luck. That's crazy.
My thing's
What is
lost.
it? Second squared?
Look where it is.
It's
Yeah.
just second.
So,
Squared.
and this is 2.
It just puts a radical and I mean, not radical. See when I go to delete it, it just skips over.
Maybe yours, yours is weird. I'm just out of bar.
We're going to it, right?
Do you have the 84 plus?
83 plus.
Yeah, we'll probably do the same thing here.
Is it putting random parentheses again?
Yeah.
Yeah.
That's our
what
problem
mine's
too.
doing.
You should just not do this. Or just skip it. It's unfair for people. Right, it's just
Oh, wait,
unfair.
it's right there. It's right there. You're so smart. Thank you.
That one's good.
Really good.
Yeah.
They changed the cream cheese. It's so bad.
I don't
You have butter.
I'm recording too. I'm just giving out.
It's like an insect.
I know.
No, I do. I just don't want
It's
to
so
do it.
here.
Yeah.
They changed it every single year. Before it was like actually like cheese. Now it's like it's even cheese. It's like cream. It's like dairy.
Yeah, I don't like it.
It's not good. They were good though. Like everything else is so bad, but they were really good. Or they were really good from.
Yeah, I gotta figure right. I don't know. I'll figure it out. Maybe I won't be looking at this.
Oh yeah.
All right, guys, let's keep going. The 83s and the 84 pluses are very complicated with their parentheses. It doesn't look like this, but if you're in the CE, it should look like this, right? So now you're at the second trace. We're going to a minimum. Looks like we're at 3.5 for our x minimum. So now our x coordinate is 3.5. Now our y, be careful, our y coordinate is not 1.94. What does 1.94 represent?
It's the thing. Yeah.
What does 1.94 represent? The what? The perimeter? No, no perimeter here. Root x? No. What does the 1.94 represent? No x, no. The distance. This represents the distance between the 2 points. The y represents the distance between the 2 points, not the y coordinate. So to find the y coordinate, what do we have to do? We're going to take y is equal to root 3.5. So in your calculator, can you guys type in second root and then 3.5 and tell me what you get? Give me 2 decimal places. 1.87. So our point on the shooting star that's closest is 3, 1.87.
Not 3.5.
What happened?
Not 3.5.
3.5 comma 1.87. That's the point, right? A coordinate is x comma y.
Yeah, I thought you said 3.
Mm-mm. Okay, let's go to number 4. Let's go to number 4. We'll try to come back to number 3 if we have time, but I want to switch this up. An open box is made from a rectangular piece of cardboard that is 10 inches by 7 inches, cutting out congruent squares from each corner. Find the maximum volume of the box and the size of the squares that need to be cut out. This is very similar to what we did last time, right? We have our box, our rectangular sheet. And what are the dimensions of this sheet? 10 by 7. But what's happening? What are we doing to this sheet?
Folding it.
Cutting out what?
Oh, the squares.
Cutting out squares from each corner. Do we know how big these squares are?
X.
X, very good. So what's going to happen is once we cut out these squares, cut all these out, I'm going to fold these up, right, and make a box so it has some depth to it. But now when I go, the length, after I cut out these squares, the length is no longer 7. How am I going to represent the length? 7 minus 2x. And now once I cut out these squares, right, our width is no longer 10. How am I going to represent the width? 10 minus 2x. Perfect. So it says find the maximum volume of the box and the size of the squares that need to be cut out. So it says find the maximum volume. So we know we're using volume. How do you find the volume of a rectangular solid? Length times width times height. And now our length is 7 minus 2x. Our width is 10 minus 2x. What is the height? X. Excellent, excellent, excellent. Is there another equation here? No, this is it. Everything's in terms of x, right? We don't need another equation. Everything's x. I will tell you the window. The x window is going to be 0 to 10. The y window will be 0 to 100. So we want two things. We want the max volume, but we also want the size of the squares that need to be cut out. All right, let's go to our calculator. All right, this is what it should look like. Do we see a maximum here? Can somebody tell me why am I not even looking over here? Does anybody know why I'm not even looking over here at this part of the graph?
There's no clear like curve like max point.
That is a good sign because there's no clear curve. But I'm saying for it to make sense, think about this. Right. We know that this is 7 minus 2x, and we know this has to exist. So if that's 7 minus 2x, we know that has to be greater than 0. So then this is telling us that 2x will be greater than 7. So x has to be less than 3.5. This is telling us x has to be less than 3.5, which tells me anything beyond this won't make the rectangle work. Or you could just look at it, this is a clear maximum, so let's just focus on that. All right, so did anybody find what this maximum was for the x coordinate? Nika? 1.35. So our x coordinate is 1.35, but what is the max value?
That's the y.
That's the corresponding y. Yep. What is that? Max volume is not 5, no. 42.38 if you round, right? 42.38.
You want us to write out like max volume, or you just write y?
No, I want you to write max volume. So the size of the square is a 1.35 by a 1.35, right? Because the sides are all the same in a square. So when they say the size of the square, it's a 1.35 by 1.35.
Yeah, so you gotta write it.
Mm-hmm. Okay, how much time do I have left? Can I do one more? How much time?
8 minutes.
Oh my goodness, stop it. We have enough time.
So I generally use the bathroom.
Yeah.
I'm not skipping it.
All right, let's do number 6. Find the coordinates of the point on the curve y equals x minus 3 quantity squared that is closest to 7, 4. All right, so what is y equals x minus 3 squared if we were to sketch this? Yay, this is a parabola. So let's just do a quick sketch of this parabola. Do we agree this is a parabola that has been shifted to the right 3? So it looks something like this. Just doing a sketch. So we want to find the point on this parabola that is closest to the point 7, 4. 1, 2, 3, 4, 5, 6, 7. So we want to find the point that's closest to this point that is 7, 4. Because I'm talking about the distance between 2 points, what do I have to use now? The distance formula. Yes, distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. Now we have a couple of things here. We have the point 7, 4, and we have y is equal to x minus 3 quantity squared. What am I going to do with the 7, 4? What am I going to plug that in as? Good, x2, y2. So distance is going to equal 7 minus x quantity squared plus 4 minus y quantity squared. Now we do have a problem. We do have a problem because this is still x and y. We only want it in one variable. But don't we have that y is equal to x minus 3 quantity squared? So anytime I see a y, what can I put in? X minus 3 squared. So that's what we're going to do. So we're going to have d is equal to the root of 7 minus x squared plus 4 minus, open your parentheses, x minus 3 squared. Close your parentheses, and then we're squaring it. Oh boy, this is going to be obnoxious.
What's the window?
The window is going to be 0 to 15. We got to figure something out for the pluses. I don't know. All right, the window for x and y is going to be 0 to 15, and y will be 0 to 15. Look, let me give you my calculator and see how you do with it. Did the window work?
Yeah.
All right, what did we get for x? No? Mm-hmm.
5.109.
I did not get that. Hold on, let me type it in.
I got 5.79.
5.79. Okay, so you guys we might have gotten the same thing. Okay, so here we're going to have, let me just type mine in. Second root x minus 7 squared. Oops, sorry. Nope, that's not what we had. We had 7 minus x, doesn't matter though, squared plus, then we're going to have 4 minus parentheses that look right?
Yeah.
Okay.
Window.
Window 15 and 15. There we go. Is that how yours looks? Okay. Luke, were you able to get it on my calculator? Yours looks a little bit different. Okay, so what did we get? 5.1? Okay. So we're 5.1, and then our corresponding y value will be 5.1 minus 3 squared. You just have to put that into your calculator. What was it? I don't know. Whatever that was. So we are done here.